Hey everybody, this is Mr. Roche coming to you live from the STEM Center in Southbury, Massachusetts. And what I wanted to show you what I wanted to do tonight was get timing going for our sorting algorithms. Okay, this is my sort main. You guys have pretty much the exact same thing. This is my selection sort, which we programmed yesterday in class. So we got this awesome code over here. Okay, and we're just gonna basically try to run it. And it would be great if we could get a best case, like random case, and like worst case scenario here to get some times for these things. Okay, so first off, you got to set up timing. Okay, so I'm setting this to like 10,000 numbers to sort. Okay, and I'm gonna run it right now, and I'm gonna get a time for it. Look, I'm gonna save it. And running it, what happens is I run it and it runs, and what I got here is I got a nanosecond time. Okay, so it does 10,000 numbers in 85 million nanoseconds, and 1 nanosecond is a millionth of a second, I believe, something like that. So and what I did was I divided the second time by a million. Okay, and then I figured out a way to like kind of round them. So I rounded it up and said got a thing of like 0.9 for 10,000. Okay, so let's do it like if you want to do it for more meaningful stuff, let's do it. Like, do it for like 100,000 at least. Okay, so I'm adding one more zero, and it takes my poor little computer. Switch the processor that it has 2.85 seconds to do this on an order n squared algorithm, which is like the slow kind of algorithm, right? Okay, but 2.8 seconds is something. So if I put it in a million, what's it going to be, kids? It's going to be a lot. So anyway, I'm going to run it, and then we'll check back on it. Okay, so here we go. Here's a million, and it's actually going to take some time to do this. This is the point. So if you imagine how many people are in the United States, for example, or how many people are in the United States and China, and Korea and India and England and France, and you had to like kind of get a number for all of them. And you had to actually sort these people. It could take a substantial amount of time. Here we go. Okay. So it's working. Okay, that's what's sort of happening right now. Okay, but let me show you while it's working. What we got. Okay, so what happened was, this is in main. I'm in main here. Okay, so in main, what I did was I created a new object, a selection sort object. You have this. We used our constructor to create a selection sort object. Okay, then what I want you to do is we in the code in class we created this thing. We said num list, and then we called the selection sort routine on our sort object. Okay, so we create sort here. And then we're going to call the sorting routine for it. Okay, this is where we actually sort. Okay, I actually wrote that right there. Okay, so it's very, very clear. In the meantime, what we got to do is get a system time for whatever time the system thinks it is at the time right before we start the algorithm. So this is like starting our stopwatch. Okay, this is like start the stopwatch. So we'll say like start like that. Okay. And Luke was great to figure this out, and we sent this along. He's using nanotime, and I think it's a good thing. And what happens is it comes with a system, so it's like kind of a system dot out print thing. So it's just like system dot nanotime. So what I want you to do is write this command right in there above selection sort. Okay. You're gonna have to do like an organize. You don't even have to do an organize input because it's like system, so it's like no problem. Okay. Then what you want to do is, so we have this. We need to find the start, and then the end, and then what you do is you subtract the end from the start, and that's how much time it took. Okay. So you have to make this command right here. Start time equals system dot nano time. Okay. And these are a long integer numbers you're getting back. You're getting back the super long integer. Okay, so it's like a 64-bit number, which is pretty big. So it's like 2 to the 64th, the size of it. And we have to get an n time. So you have to write this line here to get n. Okay, and we'll like highlight that too. Okay, so you guys are writing this. I already wrote them out or whatever. Actually, Luke typed them in. Start. This is like the end. Okay, and then you have to write a line here at the end to get the whatever the time is, and that's like basically the ending time that you got from the stopwatch of the time of the computer minus the start time. Okay, so the the time equals end minus the start. Okay, in terms of nanoseconds, so you're going to get this sort of nanosecond value. Okay, so you want to get this line in here for homework. You want to get this line in here for homework, and you want to get this line in here for homework, okay? That would be like for the first steps. You got to get 3 lines for homework. That's not bad homework, right, so far. Okay, then what I want to do is we already have this. We print out the array, okay? This is what the sorted list looks like, okay? And like notice that my million thing is still working here. See this? Okay, I'm really hoping it's going to work before like the next class starts and stuff like that. So anyway, it's still working, which is amazing. Okay, so a million things takes a long time in an n squared kind of situation here. Okay. Anyway, okay. So what we gotta do is do this, and then what you want to do is you want to print out the time in nanoseconds. So you want this line to be printed. So you're gonna make another system out print line. And you can say time in nanoseconds, right? And then what you're doing is you're just printing out this timing value. The print line's smart enough they can handle along with the string, so that's fine. No worries. Okay. But then what you want to do is you want to kind of convert this to seconds, because like everybody loves nanoseconds, but nobody really knows. Nobody wants to sit around and go like, oh, it took 45,000 nanoseconds. That doesn't seem good. So we'd like to get some kind of seconds for this. Okay. So since 1 nanosecond is a million seconds, okay, if I just divide timing by a million, and I'm adding a 0.0 to give me the decimal numbers, because if I don't, it'll give me like an integer, and I make sure this is a kind of a CAS conversion to make sure I'm going to get a double, I can put this into a fractional value and get a double value, which is good. I want that. Okay, so that's my time in seconds, and I'm going to print that out. Okay, then nobody wants to find out that it's like 6.2576892 seconds. That seems kind of lame. So what I wanted to do is I wanted to round it. So I'm going to do one more thing, and I'm going to write a system out print line. Okay, it's going to round to 2 places, and if I round to 2 places, what I can do, this is sort of a trick, is that I can use math round, and math round gives you like a rounded integer, but if I multiply it first times 100, it'll kind of move it over 2 places, and then if I divide it by 100, it'll put the 2 places back, and that way I can get a good round, and there you are. Okay, so what we want to do right now is get that done. Okay, and then what I want to do is do something to give you a best case, worst case, and kind of intermediate case scenario. So what we need to do is actually generate, like right now we're generating like a whole bunch of random numbers, like see this loop here? This is like the medium case. And what we're going to need to do is generate a loop that's like, they're all going like from 1 to 0, or from 0 to 5,000, just count them up, and then, or from a million down. It's like something like that, which we can do. Okay, because you could write loops that would be like best case loop, medium case loop, stuff like that. Okay, so anyway, that's the deal. I'm sincerely hoping that my thing comes back. I think what's going on right now, it actually did come back. Look at this. It came back, but it's taking so long to do the system out print line that it's like printing. Look how many ones come back all sorted and stuff like that. That's a good sign, but I'm not done yet. But actually the thing is that this is just handling the print part. So like we're kind of already done. So we already have the times and stuff like that. So it's fine. So what goes on is that we actually get our number back here, and we let me see. We do our sorted list, and then the thing is, all this right now is happening here, but so we already have a value for start time and end time and stuff like that. It's just taking so long to print. So there it is. Okay, there it is. Okay, so it took me 291 seconds to get this printed. Okay, I mean to get the sort done. Okay, that's a long time. Okay, it's definitely more than a couple of minutes, right? Okay, so anyway, it's like 4 minutes. Maybe about 4.5 minutes, something like that, to get it printed. So yeah, almost 5 minutes. So anyway, that's what I got for my medium case, okay? And what I want you guys to do is get this done, okay? So you can pause the video right now and run it. Make sure you get something that looks like this. See, I'm getting these nanoseconds, and then I get conversion to seconds, and then I get a time. So make sure you get that, okay? And then we'll work on getting the cases.